Hey, good morning, ladies and gentlemen. Greetings from my Stockholm's office. My name is Lubos Lunter. I'm prepared for today's webinar session. Before we start, let me share some instructions. As usual, we are using GoToWebinar software for the webinar. All attendees are muted in default. Please let me know via the chat application if there is some trouble with audio, video, or presentation. And of course, if you have a question during the webinar, just use the questions application and I will be trying to check the questions during the session. And at the end of the session, I will definitely check all the questions and I will make sure that there is no question without answer, or if there is some specific question, I can still forward it to my colleagues and to make a follow-up. Yeah, it seems there is a lot of attendees already here, so yeah, just let's start. I will check if there is some message regarding the audio quality or the other stuff. It seems that everything is okay. Well, good morning to all of you. Thank you very much for joining the session. Today's topic is encrypted traffic analysis. My name is Lubos Lunter. I'm product manager at Flowmon Networks. And let's take a look if encryption means zero visibility or not. Before I will jump into the encrypted traffic analysis, let me share some summary of news within the Flowmon 10 for our new release. Brought some specific news. The first is improved user experience, so new modern feel and look of the graphical user interface. The second, which is definitely the most revolutionary, is distributed architecture and centralized management of multiple collectors, and decentralized flow collection flow processing. That means that it's easy to set up one centralized system and distribute the workload. So if you imagine that the top model of collector can process 400,000 flows per second, when connecting multiple of devices, you can scale to the really huge numbers. So this is definitely for the biggest deployments and biggest networks. Another cool stuff is the native monitoring of IoT, SCADA environments. So we have added special IoT and SCADA protocols. That means that this is something in the field of enriching flow with layer 7 or with specific protocols to get the visibility beyond the standard layer 3, layer 4. Another nice feature, which is not in the Flowmon monitoring center and on the collector part, but this applies on the Flowmon traffic recorder, the module for on-demand full packet capturing. There is a new feature which is rolling buffer. That means that you can you can do on-demand full packet capture. That means to store the PCAP of the raw data communication even before the capturing starts. So you can catch packets from like, for example, 5 minutes in the past. So once you start the traffic recording, you can store information from the traffic before you start to record. This is also nice in combination with Flowmon ADS security module, and there is integration. So once the network behavior analysis module finds deviation in the traffic and detect some security threat. It can automatically trigger the on-demand full packet capturing. But now with the rolling buffer, you can have in PCAP also information which really caused the like triggering the security incident, because there is a rolling buffer which ensures this. And the most important news and today's topic is encrypted traffic analysis. So let's jump into the topic right now. Encrypted traffic analysis by Flowmon networks. Why this is important? Of course, we observe that the volume of encrypted traffic in the internet traffic is increasing. On the left side, you can see some numbers from Cisco Security Research that in past year there has been 12% increase in the volume of encrypted traffic, web traffic. Another report from the 2018, the Global Internet Phenomena Report states that more than 50% of internet traffic is encrypted, and they have also noted that the adoption of the TLS 1.3 standard is also growing. But why this is important for us from the security perspective? This is because threats are moving to the encrypted traffic as well, because attackers knows that hiding in encrypted traffic means lower probability of detecting their malicious behavior. So that's why reports state also that there has been an increase in the malicious binaries hiding in encrypted traffic. On the left side again, numbers from the last year, and you can see the real huge differences comparing the last year's numbers, and also some prediction that in the next year there will be also increase in the numbers of hiding malicious traffic in encrypted traffic. And why is this important for us? This is because the report states that 60% of organizations can detect malicious SSL traffic. And here we can, I think it's more complicated, because if we ask somebody about the ability to detect something in SSL traffic, they obviously would consider that they have SSL decryption. They could have SSL decryption in front of the application servers, but this is something which brings the visibility for the traffic going to the application server you are administrating. But still, there is almost no visibility and information about the traffic, like in the east-west traffic from one endpoint to another endpoint within the one enterprise network or within the data center. And also another prediction from Gartner that in 2019 they expect that 80% of the traffic will be encrypted. So this is something we really need to address. And how to address this? Let's take a look how we at Flowmon look at encrypted traffic analysis. We can divide, or we can split it into two topics. The first is the analysis of characteristics, patterns, behavior, which mean not the decryption of the traffic. It's using the layer 3, layer 4 information such as source, destination, IP, port, protocol, timestamps, and data volumes to be able to see the differences in the traffic without the need of decryption. So that means that network behavior analysis as a technology is so robust using this L3, L4 information that a lot of use cases, there is no need to have the real visibility into the payload, because having this visibility into the payload is really resource consuming and sometimes not applicable if we cannot imagine that every packet will be decrypted, and like SSL decryption is man in the middle concept as it is done for the application servers. And the other part is, which is right now new in the Flowmon, is leveraging of unencrypted parts of the TLS traffics, which means using the TLS handshake protocol, which is not encrypted but stores a lot of useful information for use cases in the area of cryptographic assessments, watching for TLS policy compliances, cipher suits, and key lengths and certificates information. So we can recognize here two types of use cases. The first is the monitoring and security, where we use malicious patterns in the encrypted traffic. And the second is the cryptographic assessment and watching for policy compliance. I mentioned the new feature, and which means SSL and TLS visibility. This is something which is aligned with the long-term strategy of Flowmon and enriching flow with layer 7 information, which can be useful for troubleshooting use cases, operational use cases, and of course security as well. So this is something which enriches flow and enriches use cases where the monitoring and the security can go, and how it can go beyond the standard flow information. So when we talk about the TLS visibility, that means that there is visibility in the TLS session, client information, certificate information, and JA3 fingerprint, which is used in the threat intelligence. In the roadmap, we have another protocol with this from this family. It's SSH, and we will bring this kind of visibility into SSH protocol as well in the future. So let's take a look how it looks like in the use case with the net flow, with the standard layer 3, layer 4 information. So on the left side, we have a network. There is some router and switch from which we consume net flow to the collector, and there is the net flow fields or data, the metadata or the telemetry, network telemetry is stored on the collector, and there is done the network behavior analysis. So we have the visibility into layer 3, layer 4, we store the information, we run machine learning algorithms over that to be able to provide early detection and response. Here that means that having collected all the information on the collector, we see the characteristics of the traffic, we see the volumes, IP addresses involved in the communication, and we can, using the machine learning, we can find out there is something different. So we do not need a signature. We do not need the payload of the information. We just need to do the proper analysis to profile endpoint servers to see what has been changed from the normal or some kind of baselining or long-term learning about the patterns of the users in the network. Extended visibility into SSL TLS obviously requires Flowmon probe in place, because Flowmon probe is standalone appliance which has access to the raw data. So that means it sits on tap or on span port, mirror port of the router or switch. And the raw network data comes to probe, and the probe does kind of deep bucket inspection. So it picks the relevant information from the layer 7 and of course from the lower layers as well, and stores it into the enriched flow or IPFix standard and stores it on the collector. Having the probe in place, we are able to do the same as with the standard flow from the routers and switches I've shown on the previous slide. But on top of that, we can bring the SSL and TLS visibility, so we can extend the security use cases such as policy compliance, inspection of cipher suite certificates, and the audit. But how it works, what it means for us to have the SSL and TLS visibility, how we get the information and what information do we have. This is, I mentioned before that we leverage the SSL TLS handshake protocol. We have client, we have server, there is a probe, so all the communication or the probe has the visibility into the raw communication between the client and server. And at the beginning, there is establishment of the security capabilities. There is exchange of the protocol versions. Session ID is assigned, cipher suites, and other information. Then server may send certificate. There is a key exchange and possibly it could be the request of the certificate, and then this is ended by server hello done information. Then client sends a certificate if it was requested, sends a key exchange, and also can send certificate verification. And here we can see the end of the protocol. From this handshake, there is exchange of the information regarding the cipher suites, public key algorithms, public key encryption algorithms, public key lengths, certificate validity, name of the certificate authorities, and the others. That means that all this information is parsed from the traffic and stored together with flow data on the collector, which allows us to work with data in the standard way. So to summarize, we have information from IP header, TCP header, TLS header. Here you can see which kind, or this like the snapshot of which information you can imagine under the got from the TLS header, stored in the IPFix enriched flow on the collector, and use cases. So then we can do the network behavior analysis, and we can provide the SSL TLS policy compliance use case. And let's see what it means to have or which use cases are covered in the encrypted traffic analysis. So first of all, it's good to realize the differences between HTTP and HTTPS. I believe that you know the theory behind, but let's be like quite explicit here. This is a screenshot from Wireshark having we can see which information is visible in Wireshark in the raw network data when using HTTP. So we can see the real application data information. Here is some HTTP website information, including the all the content on the website, and if there is some data transferred, it is visible. So if there is everybody who has access to the network data can see what was sent between client and server in the communication. Then the other screenshot is on the communication using HTTPS. We can just see that there is TLS 1.2 standard used, and then there is information about encrypted application data. So there is no visibility about the content, about the payload of the communication. Yeah, which is good for attackers when hiding the data in this kind of traffic or in encrypted traffic, because they realize that if it is not visible, easily visible, it is also there is a problem for the monitoring tools, a lot of monitoring tools as well, because if they use like the deep packet inspection approaches, that they are not able to find this malicious communication because it's encrypted. So let's see one of the use cases where we can leverage this network behavior analysis. There is a BitTorrent traffic detection as an example. Yeah, just to know that the standard TCP ports of the BitTorrent traffic are 6881 and up to 6889, but just blocking the standard TCP ports doesn't work, because nowadays BitTorrent applications use port number randomization. Otherwise, it will be very easy to block them on the firewalls. So the other option, how to detect that there is some BitTorrent traffic, is to look for some signatures. Yeah, that there are some signatures which shows that there is BitTorrent traffic, but this could work only in the case that there is not encryption in place. So if there is HTTP communication, we can apply this kind of signature approach, and we can look in Wireshark for these signatures, or some deep packet inspection solutions, or some packet analysis solutions can do this kind of analysis. But it simply doesn't work nowadays, because the default for almost all BitTorrent applications is that the traffic is encrypted. So that means using TLS. Another option is to use flow-based encrypted traffic analysis, and this is every communication has some pattern. BitTorrent client makes a lot of connections with peers in a short time interval. This is something which is detectable from the flow data, from the layer 3, layer 4 information. There is just a lot of computing behind, and the machine learning needs to be in place. Another characteristic is that peers are distributed over the globe, so this is something which needs to be considered in the algorithms. And also many connections fail because peers are offline. So this is like comprehensive description of the pattern, which can be detected on the just on the behavior and characteristics of the communication, not the payload. So here, instead of having the visibility into the payload and looking for the signatures, there is used another approach to see the characteristics of the traffic. Another use case is from the family of the TLS visibility and as cryptographic compliance, and which can be reporting on TLS protocol version or inspection and alerts on vulnerable TLS protocol versions. So all the information is stored on the collector, and you can just filter it out as you need. You can create your own alerts, and you can do inspections. So if you can adapt or apply your company policy and look for unsupported versions here. Another use case can be weak public key length and algorithm. So there are a lot of vulnerable algorithms. That's why we are moving to standard TLS 1.3, but still you can find this low encryption in the traffic, and to identify it, it's super easy to find it among the flow data because all the information is stored there. Yeah, here is an example of the filter, how to filter out for, the traffic for the weak encryption. There is some also the output, so you can filter out the traffic. Then you can see, you can watch. Of course, for your servers, you can watch for hosts and do the investigation. And here is an example how to set an alert. So you can easily specify for which, so you can filter for which IP addresses you would like to make an alert. And here an example shows us TLS valid to date. So if you would like to find out expired certificates, you can just make an alert. But obviously, it will make more sense, for example, to set an alert to be alerted on certificates which will be expired in 1 month, and you can have this these alerts for your servers in the networks, and you can easily watch for or you can prevent to expiration, or you can prevent from expiration of the certificates in your network. Okay, that's it from the presentation. I will jump into the live demonstration right now and just quickly show you the graphical user interface and some use cases in the online demonstration. So hopefully you see right now my my web browser. Otherwise, please let me know if you see still the presentation. This is our online demonstration. It's public accessible. You can play around, find the link on our website. Here, at first, I will jump into the configuration center. It's important when you have Flowmon probe, or if you use monitoring ports of virtual appliance of flow collector, because this is something you need to use to get the TLS visibility. So as I mentioned at the beginning, either Flowmon probe or the virtual appliance of Flowmon collector has a capability of inbuilt probe. That means that it has monitoring ports where you bring the raw traffic, and the probe generates the enriched flow in IPFix standard, and you need to set the extensions, so which extensions you would like to see in flow data. So this is something you need to double check before you use the TLS information. And of course, it will be clever to optimize the layer 7 information which you store. So because this is something which consumes resources or storage capacity. So it's always clever to store only the data which you really use in your analysis, profiles, alerts, and the other stuff. So once you have this set in the configuration center, we can jump in the monitoring center, and let's take a look. Yeah, let's use the analysis, as this is the interactive way how to visualize the flow data, and I will show you the TLS outputs. So I will use a profile, HTTPS and HTTP. The profile filters out the relevant traffic for us. Obviously, the TLS traffic will be included in the HTTPS channel here. And once we would like to, for example, investigate for the certificates or the TLS information, we can just highlight the time interval here, and we can either display statistics or list of flows. Here I use the output extended TLS. That means that the items in the table will show me the TLS information. Otherwise, the default view shows you like the standard flow information. And now let's take a look what we can see in the outputs. So here, yeah, here is some HTTP traffic. I didn't filter it here in filter, but I can use a filter as well. And here we can see that there is included for the HTTPS traffic, TLS issuer common name, TLS certificate validity from validity to. So we can watch for expiration, TLS public key algorithm, public key length, common name, and other informations. So this is really good for when you are watching for some. For example, we can use a filters to filter out some low encryption algorithms, or so let's use TLS, the TLS public key algorithm. Let's say RSA. And TLS public key length is and now we can filter out the traffic using some weak encryption. And we can here see source IP addresses, destination IP addresses. So it would be clever to use these filters for investigating your networks. And if you have some policy and some supported protocols, you can even use alerts. And I will show you how to set up an alert using the information. And as you know, you can use each information stored on collector to create your own reports, alerts, profiles, so you can work with this data as you need. It's really flexible for you. So here is an alert I've shown you in the presentation, but you can imagine another filters here. So once there is some specific or once you discover that some encryption algorithm is vulnerable, you can create a list of vulnerable algorithms, and then you can trigger an alert every time once this kind of algorithm occurs in the network traffic, and this is something which really allows you to leverage this data. And in our plans, there is also improvements in the anomaly detection system and the network behavior network behavior analysis. So we will be able to use all this TLS data in the ADS as well in the future. But this is something which is under development right now. So that's pretty much it. It's from my side everything I had prepared, and I'm curious if there are some questions from your side. I will be happy to answer all your questions right now. So let me check. Yeah, I have one question here. What is the consequence on the storage capacity of collector when collecting the layer 7 information? Yeah, this is something when you store the like the standard NetFlow fields on the collector, that there is like the common number of aggregation is 1 to 500. That means that 1 terabyte of traffic is converted to 2 megabytes of flow statistics. When using layer 7 information, yeah, depends. Here depends really on the traffic you monitor. It can be like it can decrease this ratio to 1 to 300 or 1 to 400, depends really on which kind of layer 7 information you store and how the traffic, how the monitor traffic looks like. But this is always the best option is always to make the POC before to download the trial appliance, put it in your infrastructure, and you can then see, you can use the monitoring ports of the collector to use the probe capability, and then you can exactly see how much IPFix data is needed to store the flow information about the network for 1 week, 1 month, or this is the way how to do that properly. Thank you for the question. Any other questions? There is still not other question. Okay, in case there is some another questions arise, just feel free to drop me a line. And of course, if you have any informal questions, just use LinkedIn, connect with me on LinkedIn, and drop me a line via LinkedIn. We can chat about chat about these topics anytime. Thank you very much for attending this session, and see you in the future. Thank you. Goodbye.